because it's too long. Can you teach me in like 5 minutes? Right when I'm standing in front of you? Okay. So let's move on. So let's see. We're going to talk about ionic bonding first, all right? We're going to talk about ionic bonding first. It was very interesting. Write the formula of an ion. Till date, I have kids, when I ask them to make an anion, they subtract electrons. When I ask them to make a cation, they add electrons. How are you going to learn about the human body and become a doctor if you just can't play with 3 different subatomic particles? Really? The atom has only 3 things: protons, neutrons, and electrons. And they can't get that wrapped around their head. How are you going to learn about your body, or how are you going to become an engineer, which is so much more complex? You need to keep things in your head. 3 things. Write the electron configuration for an ion. Unbelievable number of students had subtracted instead of adding for an anion. Okay? So get this straight. A cation is a positive ion formed by the loss of electrons, and anion is a negative ion formed by the gain of electrons. Now these are ions. Okay? Now, where do you think ions will be involved in? In ionic bonds, in covalent bonds, in metallic bonds? Where will they be involved? Let's think exactly. Really? All right? Ions are involved in ionic bonding and in metallic bonding actually. All right. Now, what element is this? It has 3 rings. There is one in the outermost ring. It is sodium. What about the other one? There are 3 rings. There is 7 in the outermost. It's chlorine. This is sodium and that is chlorine. This desperately wants to lose and that desperately wants to gain. And therefore, all right, which are the electrons that are involved in bonding? The valence electrons. And what happens to sodium? Sodium transfers this electron to chlorine. Is that right? There is a complete transfer of electron, and sodium becomes bigger or smaller?
Smaller.
It becomes smaller, and what happens to chlorine? It gets bigger, that is Na plus, and this is Cl minus, and because they are now ions, there is a strong force of attraction. And what is that force of attraction known as? Ionic bond. Alright? It's between ions. It's called an ionic bond. Do we understand how ionic bonds are formed? There is a complete transfer of electrons. Now please understand this. We talk about ionic bonds and we talk about covalent bonds. Alright? So we just saw an example of an ionic bond and the formation of ions, plus and minus. Is that right? Now, let's look at water. Okay? Oxygen has how many valence electrons? 6 valence electrons. Each hydrogen has how many valence electrons? 1. Hydrogen is stable with how many valence electrons? Does it need 7 more? Or is it stable with 1 more? 1 more. It is stable with 1 more. Okay? Those are the 2 exceptions, hydrogen and helium. Is that right? So, when hydrogen combines with oxygen, it cannot transfer the electron completely to oxygen because then it doesn't have any electron of its own. It becomes highly unstable. Is that right? So what happens to this pair of electrons? We say they are shared. In an ionic bond, they were transferred. Is that right? 8th grade, exactly. You can pass my chemistry SOL with 8th grade science. All right? Exactly, I know that. All right? Now, this is also shared. Now, you will learn this way even in 10th grade. Oh, ionic bond is a transfer of electrons, covalent bond is sharing of electrons. And you will also learn, we will take notes, all right? An ionic bond is always, if you look at a periodic table, all right? An ionic bond is formed between a metal and a non-metal. An ionic bond is always formed between a metal and a non-metal. Metals want to lose, non-metal wants to gain. Do you understand that? If you look at a covalent bond is generally formed between two non-metals. Well, hydrogen is on the metallic side. Is hydrogen a metal?
No.
Hydrogen is neither a metal nor a non-metal. All right? Or if I want to make another covalent compound, say I take phosphorus, I take chlorine. Are they both on the non-metal side? Right? Phosphorus has how many valence electrons? Phosphorus has 5. Each chlorine has 7. Is that right? So it combines with how many chlorine? With 3 chlorines, it shares and you have a compound. So sharing of electrons takes place in a covalent bond. Transfer of electrons between a metal and a non-metal takes place in an ionic bond. True. All right, let's make sure that we write all this down. Make sure we write all this down. They are transferred, there is unequal sharing, and there is equal sharing. We will come to what is metallic bond in a little bit. Did you understand what transferred means? Did you understand what the word transferred means? When we say sharing of electrons, let's look at PCl3. We said it shares 3 electrons, with each of the chlorine. Yes or no? Now, what we need to pay attention to is there is a pair of electrons between them. Is that right? One atom is phosphorus, one is chlorine. Will the pull be equal on the pair of electrons? What is that word for the pull of electrons called? That's not ionization. It's not electronegativity. What is it called? Electronegativity. Alright? This pull for the 2 pair of electrons is called electronegativity. And smaller the atom, the more electronegative it is. Yes or no? Therefore, chlorine in this case will have a greater share of this pair of electrons. Yes or no? It's more towards chlorine than it is towards phosphorus. Chlorine pulls the pair of electrons. So even though there is sharing, we say there is unequal sharing. Unequal sharing leads to polar compounds. Does that make sense? But if I take, say, 2 chlorine atoms, chlorine has 7 and one more chlorine has 7. Is there any difference in electronegativity between the 2 elements?
Yes.
Chlorine and chlorine. Is there any difference? So there is equal sharing and we say the bond is non-polar. It's not pulled more towards one element. Do you understand that? Do you understand this concept? Now, let's check metallic bonding. All right? We need to understand metallic bonding. So how do they explain the structure of metals? What is it at the atomic level? What keeps the atoms together in the given compound? I want you to draw a picture. Okay? Now, let's think of any metallic atom. 3/4 of the periodic table consists of metals. Is that right? There are more metals than non-metals on the periodic table. I can say magnesium. You work with a magnesium strip. Magnesium has how many valence electrons? 2. So what each magnesium atom does is, it gets rid of its 2 valence electrons and it remains as a magnesium cation. Alright? So each one is a magnesium plus 2. Alright? And there is and all these electrons are released from the metal atoms, and we call this the sea of electrons. Sea of electrons. The sea of electrons act as a glue and keep all the metal cations in its place. Keep the metal cations in its place. That's how they are held together. Now, there are a few important things you have to remember when you talk about metals. I asked this in the reactivity lab. Some kids knew, some kids didn't. All right? Metals are in your properties. Do you have a properties column here?
Yes.
For metals? Write down metals are malleable. What does the word malleable mean? You can make them into sheets. Can you take salt that you add to your food? Can you beat it into a sheet? Really, Patyam? He's nodding his head. Can you make salt into a sheet? If you believe in yourself, really? No, that's not how you believe in yourself, alright? Salt or sugar cannot be beaten into sheets. What is ductile? You can turn them into wires. Why does it happen in metals? As you beat them, this layer becomes a single layer of cations and the electrons are able to move around, and that's why, because of their structure, you can beat them into sheets and beat them into wires. Now, metals are lustrous, right? Means they are shiny. Why are metals shiny?
Because they want to.
No, that's because of their structure. Look at the sea of electrons. Remember, we talked about this. An electron is both a particle and a wave. It's both a particle and a wave. So, when light strikes a metal, the electron absorbs and reflects some of the light back. When it reflects, what do those substances have? They have a shine. And that's why metals are lustrous. Metals are not dull. The layer of oxide is dull on the metal. Alright? The next thing is, metals are not brittle. Alright? The other thing is good conductors. Metals are not insulators. Metals are good conductors of heat and electricity. Both heat and electricity, metals conduct them really well. Why? What is electricity? Rajiv, what is electricity? A flow of electrons. Alright? So, electricity is nothing. When you apply a potential difference, what is a potential difference? When will water flow? If you have water, it will flow down towards the force of gravity. Is that right? Similarly, potential difference is a similar concept. One is high and one is low, and then what will happen? The electrons will start flowing in a certain direction. That is the flow of electricity. Alright? Why does it happen with metals? Because there is a sea of electrons. Does that make sense? You understand it? Alright? So it's all based on the properties of the metals. Alright, let's move on. Did you write the types of atoms? No. Metals are formed, ionic bonds are formed between metals and non-metals. Draw a nice periodic table here. Make sure you label the metals and the non-metals. Alright? Make sure you have that. This is a very important concept. You form an ionic bond between a metal and a non-metal. Is that right? And a covalent bond is formed between two non-metals. Okay. Can you turn to the back of your sheet? Where is your note sheet? We were taking notes on a sheet of paper. We were taking notes on this sheet of paper. Look, everybody's taking notes on this. All right? I don't want students chilling. Are you taking notes on this or what?
We are.
All right. Can we go to this sheet? Can we go to the back now for a moment? Can we go to the back? Can we go to the back sheet? All right. We talked about, we will come back to it. Let's apply our knowledge. If I teach something, they're like, did you understand it? Yes. Okay? Okay, so now let's see. Is this an ionic or a covalent bond? This is what I want you to think. I just taught this to you. How would you know? Does this start with a metal or a non-metal? Which side of the periodic table? Which side of the periodic table is it? Carbon is to the right of the staircase. It's a non-metal. Therefore, the given bond is covalent. Do we understand it? Are we thinking?
It's non-polar.
All right. What about magnesium is right here. Oxygen is right there. It's ionic. It's between a metal and a non-metal. This is ionic. Copper sulfide. Ionic. Sulfur dioxide. Covalent. Are we good? You will get asked such questions. This is very fundamental to this unit.
So,
Is there anybody who doesn't understand what ionic and covalent compounds are? And how do we figure it out? Okay, I have one more example that I want to do. Jackson first, and then Sangjan, and then Burke. Let's, because he raised his hand first. Okay. Now, let's look at this compound. Barium, and it contains a polyatomic ion, nitrate. Do you see that? The bond between barium and nitrogen, barium is a metal, nitrogen is a non-metal. The bond between barium and nitrogen is ionic. But the bond between nitrogen and oxygen is covalent. So, if a compound contains polyatomic ions in it, it contains both ionic and covalent bonds in it. Do we understand that? Jackson, what was your question?
Well, we have a periodic table.
Yes, when we do naming every time, for every test from now on. Sangjan, you got offended? Okay, yes.
were those two covalent bonds? Which ones are polar? Are they both polar?
Polarity depends on electronegativity. Alright? That's a good question. Alright? And we'll answer that shortly. So do we understand how to distinguish ionic versus covalent compounds?
Yes.
When we write this down, it should make sense to us. Metal, non-metal. It actually means something. Do you understand? Now, I will get this after I finish this unit. Are you all listening? We said metal and non-metal is non-metal plus non-metal is? What about metal plus metal, Ms.Geeta? After I finish the unit, they will ask.
C is electric.
Metals do not bond with other metals. They only bond with themselves. Alright? Two metals combine and make a heterogeneous or a homogeneous mixture at best. They do not make compounds. Okay? You understand this? All right. Moving on. So that was a good question. Bert asked, how do we know if it's polar or non-polar? We look at electronegativity difference. All right? Now, when you go up to higher classes and even in other schools, this is actually the fundamental knowledge, all right? There is actually no complete transfer of electrons or there is no sharing of electrons. Everything is based on electronegativity. Does that make sense? If I'm strong enough to yank out the electron from you, I become an ionic compound. Are you listening? But if our powers are, you have some power, all right, you're not altogether weak, we make a polar covalent bond. And if both of us are equal, we make non-polar bonds. Does that make sense? This is a fundamental idea. So many times you will see aluminum compounds. Some of them will be ionic. Some of them will be covalent. You'll be like, but, that's a metal. No, it's based on what? It's based on electronegativity difference. Do we understand that? Okay, moving on. Guys, I don't want you writing down word to word what I've written here. Think. All of them are what? Solids. All of them have what? Well, let's get rid of this actually. Ionic, covalent, metallic. They both have high melting and boiling points. Is that right? What's the only different thing? Covalent. Covalents are solids, liquids, and gases, and they have low melting and boiling points. Do we get the difference? Have you ever tried melting salt?
No.
The everyday salt?
Yeah, it takes like forever.
It takes like forever. It won't melt. No, but I said solid salt. Can you melt salt?
Liquid soap.
Salt is ionic. Can you melt it? No. Can you melt sugar? Yeah.
Oh yeah, you can.
This is the festival season. I love things made of caramel, right? I love caramel cookies. Don't you? Caramel? Caramel.
Caramel or caramel?
I don't know.
It's caramel.
Okay? So,
Would you like some caramel?
see, I love caramel. That's how I want it. Okay. Everybody's thinking of cookies now. Hey, come back. You can eat cookies at home. Can we melt sugar?
Yes.
Why? Because the bond is covalent. Go ask your parents. Why can't we melt salt? I don't know. Sorry. Some of them will be able to say it. All right. Okay. Examples. I think you know to give examples. Let's see. Justin, give me an ionic compound. No, not from my book. You can't pick one of the ones that I have up there. So ionic, Justin, is between a
metal and a non-metal.
So pick a metal and a non-metal. Pick a metal and a non-metal.
Okay.
He doesn't like the
Just
thought
pick
of
one.
periodic table.
FeO.
FeO. Awesome. He's giving me a formula. He chose a transition metal. All right? All right. I don't want a transition metal. Mario, give me an example.
You're not good enough, just.
No, he's good enough. Very good. Excellent example. Au gold, again a D block.
Yes.
Okay, I like that. Gold and sulfur will form a compound. I hate it when they say K, and they go all the way to the other side and they say Ne. And they're like, aha. And I'm like, no. Why?
Because it's noble gas.
It's a noble gas. It won't form compounds. Just because I put it on the non-metal side, for heaven's sake, do not make compounds with noble gases.
Something about
Now, let's see. Covalent compounds are a little harder. The formula is a little harder to write. All right? Metals, 3/4 of the periodic table is a metal. If you cannot choose and give me an example of a metal, all right, now, moving on, let's think. Justin gave me the formula FeO, all right? I say it's a D block metal. But if he had given me calcium and chlorine, are you guys with me? Hey, are you listening? Calcium has how many valence electrons?
You.
Chlorine has how many valence electrons? 7.
Understood.
I can actually give you, the formula of the compound that forms between calcium and chlorine. Because will one calcium just react with one chlorine? There is one more valence electron. So it will react with how many chlorines?
6 or so.
2 chlorines. Does that make sense? Do you understand it? So what is the formula for calcium chloride? CaCl2. Do you understand? And iron does have 2 valence electrons, but iron can lose more from the D block. So Justin was very right in giving the formula. Iron has 2 valence electrons. Oxygen has 6 valence electrons. Will it completely transfer?
Yes.
They will combine in 1-to-1 ratio.
Yes.
FeO is the formula. But, yes, Harry. Very good. You always drive on the left side. What is the convention for writing ionic compounds?
You definitely drive on the right side.
Okay.
Don't confuse me, okay?
Don't you have your yellow light on your left side?
We're in America.
Okay.
Those outside the girls' cars.
Always? This morning? Last time?
I hope so.
Okay. All right. Now, so I keep looking at the yellow line on my left side. That's how I go by that. No, okay. I understand what I did wrong there. Anyway, the convention is to write the metal first. All right. So when you're writing ionic compounds, never ever write the non-metal first. Okay? Always metal. I'll mark it down and you're wrong.
What
Okay?
if you do covalent bonds? Like which one?
Covalent bond, the more electronegative element is written later. All right? Now, let's move on. All right, let's go to this sheet now. I think we filled out that sheet. Is that right? Okay, let's come to this one. Hey guys, the electronegativity difference. Electronegativity difference is a back of this page. Are you all listening?
Yeah. Early on.
We will come back to this table next class.
That'll last.
It's a demo, okay? And this one, you're not going to test you this year, so I'll do this later, okay? Let's go to this sheet. Now, we did this chart last unit. We said 1 valence electron, 2 valence electron. We are jumping to group 13. 3, 4, 5, 6, 7, 8. Is that right? They lose 1, plus 1, plus 2, plus 3. 4 is in the middle, then they start gaining. Is that right? Are we good? Awesome. Now, let's write down the names of ionic compounds. We are now into naming ionic compounds. All right? So if you look at the periodic table, Ba is barium. All right? Chlorine, Cl is written as chlorine on the periodic table. But then, it's no longer an element, it's now formed a compound. So, we do not write the INE at the end. What do we change it to? IDE. The non-metal ending changes. So it becomes barium chloride. So for the next one, the name will be potassium. The oxygen will become oxide. Magnesium, iodine will become
Iodide.
iodide.
Oh,
Magnesium, iodide. Are we good with the names? All right. Let's go to the bottom. All right. Guys,
Wait,
So what about
if,
LIVR?
if the non-metal has two, if there's two.
doesn't make a difference. You just write the ending. You just change the name to an IDE. So now Luke is rightly confused. Luke says, oh, this one has a 2. This one doesn't have a subscript. This one doesn't have a subscript. How are you going to distinguish them? What's going on here? Don't freak out, just change the ending. We will see how to get from the name to the formula. Now, the concept is, this is the concept. This is not how you arrive at formulas. Calcium has 2 valence electrons. Oxygen has 6. Do they combine in a 1-to-1 ratio?
Yes.
Calcium gives 2, oxygen takes 2. Is that right? But the easier way to arrive at formulas is, look up calcium.
Will we be able to use this chart during the test?
Use a periodic table.